arbitrary because of the applications that may not close the direction in the reverse for, we don't know what the time is. I think we could probably time them out after some point, but the point is you can't even set it on the first pin because you don't know when the second pin's going to come along. So that's one thing. Or you can close the one direction. That's an option. You could close that, but you would still have the other one open and you'd have to close it completely. And the only reason you do that is to save space. But so when we talk about timers, you're really talking about after you receive the fin in the opposite direction, which means that both sides have decided to close. Because the only way in TCP to force something to close, period, is to send a reset. And then if you do, then both directions have to be shut down immediately. But if you're sending a fin, you have to wait for the application to end its what it's sending and then send its own fin. And then you could set a timer waiting for the ACK to come back. So it's more complicated than just saying set a timer. You can't set a timer on the first pin unless it was a really long timer, because
yes.
you just don't know.
Yeah, so Gerald, there are, again, because of the programmability of things, I mean, you could say, I don't want to set it on fin, I want to set it on FinAC, and I want to set it on FinAC on, a particular direction rather than, both directions or whatever. So, and start the timer there, right? So there are some options there. Again,
But the problem with that is the first connection could be closed completely if you did it based on the fin and the FinAC on the first, in the one direction. The direction that initiates the fin, you can close that half down and you save space and memory. And then you can close the other direction when it's appropriate. But the only way to do that is to do that based on, you could do it based on tracking the FinAC sequence. You could set a timer there, but it would have to be separate from any timer that is based on closing the opposite direction.
Right. So, Gerald, to be honest, I haven't really read through the whole thread. I will read carefully and go through it. I just had a snippet from Reshma and I looked at it. One more point.
Also, I do want to make one point though. We're talking about implementations on your side. From a behavioral model's point of view, if we write the behavioral model and it closes it based on the fin and storing the sequence and it closes it based on that, that is the correct behavior. Whether you implement your closing based on how your hardware is optimized, based on a timer, I think it's good discussions, but remember, the behavioral model is not an implementation. It is what drives the test cases.
Right.
But it's not the implementation. You might say, geez, my hardware just doesn't support that. I'm going to use timers. And when we test it, if it tests properly and, closes connections properly, we don't care. But when we model it, I don't think we should model it as necessarily as a set of timers the way it's being talked about, because it's too close to your implementation. It should be, we know how to close the one direction down. We know how to do it with sequence number. We know it will test properly that way. We add timers. I can be convinced to add timers, but I don't want this to be an implementation discussion. This is like how building the behavioral model, because I got the test group to build the test cases. That's what I'm more concerned about, behavioral model and test cases. Your implementation, you're going to get the same test cases. If you pass the test cases, you'll be good.
Right. Gerald, one part that I didn't understand. So as far as what we were discussing, there's only one flow rule that is used in both directions. So we didn't really have a concept of closed from one direction and open from another direction kind of thing. Even when you do asymmetric, firewall, it's the same.
Yeah, it's not that it's an asymmetric anything. It's a matter of there's always two directions in a
correct. The handshake is two direction, but flow rule and you know, the timers and whatever that we are doing, they're all a single per flow.
So not as yes and no. Yes, for the most part, but think about it though. A rule is setting also is followed by what you need to encap with. If I'm or decap with two different directions, two different things. So like there are variances between the receive and the transmit. The rules on timers have to be the same, but there are differences in the rules, at least in caps and how you do that.
But that is separated out, right, Gerald? We are talking about complete table of load and not something which is a flattened cache. So if it is a flattened cache, yes, you would have different rules. But if you're not talking about a flattened cache here, the flow cache does not have details on your encap decap because that's in separate tables.
Yeah, that's in the forwarding table.
Correct.
So definitely agree that, from the application point of view, it is required for the application to close the connection and the direction comes into picture for sure. And for that reason, we have to keep it as generic as possible from the behavioral model point of view. And as long as the timers are settable, the application will be able to set it according to what it may need.
No, this is not the
and then-
application setting it, Reshma. Like, you know, that's the thing, right? This flow cache, like even in our device, you know, how long you set these absolute timer or replenishing timer is a policy on the infrastructure side as to like how long they want to allow any connection to be alive and
Mhm.
yeah.
Yeah, these timers are settable, right, Anjali, per ENI?
No, they're not in our case, but yes, yeah, you know.
But we're saying in the behavioral model they are settable for ENI because we do have different VMs from different MBAs that will have different TCB requirements, so they have to be settable. So again, that's an implementation on your side.
Correct. Yeah, yeah.
Behavior model, we want them set per ENI.
Yeah, and ENI equals to a VM, Gerald?
More or less, you can have more than one ENI on a VM, but for this conversation, just think of it as a VM.
So it's as granular as a VM, or it can be even further granular, you're saying?
It can be further, but it's on a VM. It's just that VMs can have more than one ENI.
Okay. Yeah, no, I'm just making sure we
actually
capture the requirement for whatever we tell for the next requirements.
So the ENI is matched up with the NIC interface. So like a VM can have multiple NIC interfaces.
Okay, okay. So it's equal to the interface. Okay, got it.
Yeah. And then so we don't need multiples for, like in the past we used multiples for HA, you know, we already provide HA on this. We use multiples to get more bandwidth and stuff. So it's possible for multiple ENIs to be on the same VM. Typically, we're going to try to force them to one because it consumes our resources, but it is definitely associated with the NIC interfaces of a VM.
Okay.
So yeah, so it is a subcomponent officially.
Sounds good.
Marian, had you had a chance to read through this?
Yeah, but I have a question to the conversation in general. I still don't understand why we are mixing timers with this handling. We assume that we receive every packet of the flow. How timers are related to this?
I mean, I think the timers are there because, like endpoints can go away, the power can go out, they can crash, things can happen, right?
No, but that's not the case we're talking about. We're talking about right now the case where we receive every packet. No one blacks out, everything is working.
No,
maybe
we started out talking about fragments, I think.
Yeah, we're talking about getting things out of order. We're talking about all the sequences of how you could close a connection. So we're not talking about some simple case. We're talking about.
So then we need to have, but then we need to distinguish between different cases, because there is one case where we don't receive some packet. There is a case where there is something out of order, and they are different cases.
Well, that's what we're talking about. We're talking about how to close a connection. So John sent an email itemizing the different things that can happen and why you need to close in a particular way. And this stuff is documented out there. I mean, I was reading the same book as he was reading. It's all old stuff, right? So what we're trying not to do is to build a behavioral model that doesn't reflect the error states, or not even error. You can get out of order packets. And not only that, you can get, it's not a matter of, some of the notions of even how to close are wrong, because, for example, in the Comer book, it talks about you get the fin, you ack it right away. It's not a fin ack. You ack that fin right away. It comes back as an ack. Then when the application closes, it will send the fin ack after the fact. And it could receive multiple acks for previous frames in the meantime, even before it sends out the fin ack. So, and it's even possible, if it was fast enough, that get an ack after the fin comes out. So all of those cases actually exist in real life. So what John was itemizing is there's a way to cover these cases. And where all of these things will happen naturally. They're not actually error cases. They're just cases of misordering. They're cases of how connections end.
No, I agree. Okay, I agree that there are different cases in which
and then just give it 1 second. And then he did bring up an email, just like I read too. The fin act comes later. It could come very quickly, but it may come after they finish sending their packets, which means later. So in the meantime, the reverse direction is still valid and flowing until that fin act ends. Which means that those things are dislocated for a time. You can close the one direction, but you can't close the other direction. We may use a timeout for that in case it doesn't close properly. Or we also know that we can at any time receive a reset. When either side thinks anything has gone wrong, they can send a reset, and then that's a different case. Now you have to shut both directions down because you're not allowed to send anything anymore. Reset means I'm no longer in sync. I can no longer guarantee that I've received everything. So you send a reset, you shut it down immediately. So all of those things, he talked about those things in his email. What we're saying is we need the behavioral model to have the code to deal with it like he's talking about. It's not like a behavioral model isn't a high level good path. It's all of this. And that's what we're trying to get to. And that's why we've been recruiting people or designers lately to help and go and write this code the way it, accurately down to the level that we need to test at. So when we finish, we should have a set of test cases that test every single one of these scenarios that is in his email and more. And they should pass. And if they don't pass, then we don't have a golden image for a behavioral model because it's not really that useful to us. It needs to pass because other people want to use that behavioral model to test their hardware.
So Gerald, I agree with everything you said. And furthermore, I think that this is very tricky, right? Like all the different states you can be in and all the different ways you can terminate a connection. And there are even other ones, like, for example, if you try to SYN to an endpoint that doesn't exist, that sort of partially open connection will sit in your flow table until you time it out, right? And so there's all of these cases, and I think one of the things that I was suggesting in this email was that the open contrail connection tracking expresses the logic for all of these different cases. It doesn't have timers in it. It's just the states that you can go through. And I was suggesting that we should borrow that logic as the logic that's in the behavioral model for Dash, because I believe that it covers all the corner cases.
And I totally agree with that. I don't know if it does cover the timers, and we can take that as a separate topic. But I do agree. Why wouldn't we take the well thought through, tried and true, open source that's there, convert it to the P4 model and go with it.
Exactly.
It's-
And then add the timers on top of it, right? Like,
At least then
Yeah,
we know
so
we have a starting point that's well thought out, and then timers on top of it we can debate for a while, and that's okay. And then we can add. But
I suggested my thoughts on like the timers. Like I think that there can be like 3 different timers. One for like if you got a SYN with no ACK, like you could time that out quickly.
right.
And then when you're in the established state, that's when you want to have like a lengthy timer. And then when you get the second fin, you can go back to a short timer because you're just waiting for that final ACK. So like I think that like, but all of the states are represented in that open
Piece of
contract code. Yeah.
Here.
Yeah.
Okay.
Because my fear is that like we can talk about this and like think that we understand what all the corner cases are, but I don't think you really know what all the corner cases are until you've been like burned by them.
Sure.
And, right.
I
And
agree
I think
with you. Why not do this? Like somebody has to convince me why not now. That's because it's there and it's tried and true. And it's open, right? This is open source that we can.
Yes, it's open source. Yeah.
And we can convert this to P4 and be done with it.
Right.
Gerald, I have a couple more questions. So one was, sorry, go ahead.
Yeah, go ahead.
Yeah. You said you would like to configure these timer values independently per ENI. How many different domains do you see they fall into? Because of course, keep having timer values per ENI and ENI numbers increasing day by day. I want to just be sure it's like, a dozen or something that you would look at, or it is something you're looking at like.
I think we need to look at it. We do it today. We do have VMs and we have to set these things differently, but we have default values, which we could agree on is the right approach globally. And if you don't set it per ENI, then it will inherit the default values. And then if you do, it's because we know that there's a particular implementation out there.
Right.
That requires something different.
That's a fine approach. I just want to, kind of get an upper bound of like, if there are 1,000, interfaces and VMs or whatever.
It can go there, but realistically, what we've been trying to tell people is we're trying to tell you like practical, we only have typically 32 ENIs typically on a CPU today.
Okay.
Moving to, but that's per 200 gigs. So let's say we go to 800 gig. Well, then that would be 4 times that. So that would end up being like 128. So let's say, we feel like typically 128 to 256 for an 800 gig design is reasonable. 1,000 is like kind of 1,000 is arbitrary. We don't want to like use arbitrary numbers because the 32 isn't arbitrary. It actually comes from us adding up the band. Like every VM gets a bandwidth and a connections per second. And when we mix our typical mix together, and it so happens by coincidence that the typical mix of bandwidth and connections intersect at around 30. It was around 30, so we're saying 32. And we can't get more ENIs on it because of the bandwidth. They expect bandwidth, and I expect just connections per second. So 32 for a 200 gig, 128 for an 800 gig. If you just double it and say, well, things might change. You're either going to double or subscribe. Somewhere between 128 to 256 is more reasonable. And the reason I'm saying that is when we go wild with numbers, then people's designs get out of whack, right? They start designing for
everything.
Yeah.
Marian, you had a question before.
But no, let her follow up. She.
Oh, sorry.
Yeah, so I just when you said these 32, did you mean really ENIs as 32, or did you mean the domains for these different timer settings that as 32, or did you mean VMs as 32?
ENIs, bidirectional ENIs. 32.
Okay. Okay, and ENIs are not shared between VMs.
And if you're doing 400, remember it's like 32 per 200 gig, and then you would have 64 for 400 gig.
Okay.
128 for 800 gig is reasonable, but I would double the numbers because if we oversubscribe, which is reasonable, those numbers could be doubled.
Yeah, and I just want to very quickly double confirm, right? So we said this is not a flattened flow cache model. So in that case, your tables for all the NCAP, DCAP, everything else is separate. And what we're looking at is the flow rule associated with the innermost packet, the connection, in which case it's a single flow rule for, a connection.
Well, no, hold on. What we're saying is you have those, let's say you're just talking about 200 gig and we have 32 ENIs. When you're talking about rules, it goes back to all the numbers we talked about where you have 1,000 rules per lookup, up to 5 lookups. That's where you get the dimensions of that. When you talk about the forwarding table, we have a document. Is that published, Christina?
Yeah, Gerald, maybe that.
They're
No,
separate.
Yeah, I'm not talking about the dimensions for the forwarding table. I just want to make sure that, because it came up, whether it's 2 rules per flow, one in each direction or not. That's what I'm double checking, that it is 1 rule, because all of the tables are independent.
We need Michael on it. I wish Michael would attend these calls, Christina. I don't know that to be true. In one